Hello all. In this session we will see the types of loads. In the last two sessions, that in the theory part, you have seen types of beams and types of supports. Over the beams you can see the different types of loads, right? We will see how it will look and what is the calculation method for the all the types of loads. Okay. So we have three types of loads, that is point load, uniformly distributed load, uniformly varying load. Point load is also known as concentrated load, right? Uniformly distributed, it is also called as UDL, right? Next, uniformly varying load is, you can call it as UVL. And uniformly varying load is also known as triangular load. Okay, so why it is triangular load we will see in the figure, which is coming in the next slide. We will see why it is called as triangular load. Okay, we'll just see now one by one how all these three loads look like. Okay, first one, point load. I think in the beginning of this subject and is the beginning of this session, you can see this type of load in all the beams, right? You have seen this type of load. It will look like an arrow, one arrow with the headed towards downwards, right? It will look like this. The point load is that load which acts over a small distance. Because of concentration over small distance, this load can be considered as acting on the point. That means this load will be acting only to the particular point. It is only if any structure, in any structure or a beam, this load will act only to the particular point, right? So that's why it is called as a point load and also concentrated load, right? And this point load is denoted by capital P and sometimes capital F also. And the symbol of the point load is, as I told, it will be a arrowhead which is downwards. So the point load will look like this. Next one, uniformly distributed load, that is UDL. Okay, you can see how the UDL will look like. You can see, guys, from the point A to point B, I mean from the left side to rightwards, you can see same intensity, right? Having a same intensity, that means, for example, this is a beam. Above the load will be act same throughout the length. This, if I'm taking, this is the span, it will be looking, it is distributed with the same intensity of the load. But our point load is acting only to that particular point. But UDL, that is uniformly distributed load, it is acting same intensity with that throughout the length of the beam, right? Uniformly distributed load is that whose magnitude remains uniform throughout the length. Here I have taken an example, that is, if 10k, that is a 10 kilonewton of the load per feet they are taking, is acting on a beam whose length is 15 feet, for example, then 10 kilonewton, here I am talking in the newton, but in the I have typed in the feet, right? Okay, so 10 kilonewton load is acting throughout the length of 15 feet. So here how we are taking the unit as unit, that is W by unit length, right? Here we are not marking as, for example, 10 kilonewton of load. Here you can see in the last one, P, the unit of this load is kilonewton, but here that is not kilonewton. Load is kilonewton per meter. In the explanation I have given kilo per feet, right? So here while marking the unit, we have to mark the weight, that is the load, by unit length. Uniformly distributed load is usually represented by W and is pronounced as intensity of UDL over the beam. It is usually we are not calling as a load, we are calling as the intensity of the UDL, because the UDL carries same load throughout the beam from one end to the another end. So that is all about the UDL. Next one, uniformly varying load. And I already told, uniformly varying load is also called as triangular load. I think you can see in the figure it will look like a triangle, right? That is, at the one end the intensity is exactly 0, at the another end the intensity is maximum, right? So that's why it is taken a shape of triangle. So that's why it is called as uniformly varying load. Okay, so your triangular load is that whose magnitude is 0 at the one end and increases constantly till the second end. That, as I told, one end there will be 0 intensity, gradually it will increases with the another end with the maximum intensity. So that's why it is taken as a shape of the triangle. So that's why it is also called as uniformly varying load. Thank you.